Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi for all of you class. Okay, for this video we meet again. Okay, and then on the same topic, okay, bipolar junction transistor. Okay, as we already know as BJT. And then for this video, okay, we learn on new topics. Okay, but before that, we should recall, okay, again what we have learned on our previous video. Okay, let's recall. Okay, class, we meet again. All right. So for we have a recall. Okay. So our last video we have learned how to draw the RA model. Okay, by based on the example by using voltage divider bias configuration circuits. All right. Okay. For this video, we will learn on new topic. Okay, on the AC analysis. Okay. So we will, okay, to determine inputs and output impedance with ZI and Z out, and voltage gain, which is AV. All right. Okay. So in order to learn how to determine all of these parameter on AC analysis, okay, we will focus on two circuits. Okay, two bias configuration circuits, which are, the first one is common emitter fixed bias configuration. Okay, this I assume that you all already know. And then the second one is common emitter voltage divider bias. All right, this is we have used on our previous class. Okay, and then for these two circuits, okay, we will use new formula. Okay, for the ZI, okay, equal to RB parallel with beta RE, and then ZI can be beta RE, okay, if meets condition that RB greater and equal 10 times beta RE. And then we have a Z out equal to RC parallel with R out. Okay, if you know, R out is the output resistance. Okay, and then we will use Z out equal to RC if the circuits meets the condition which is R out greater than 10 times of RC. And then we have also new equation, which is voltage gain AV, okay, equal to minus RC parallel R out divided by RE. And then if the circuits meets the condition of R out times time of RC, we will use voltage gain equal to minus RC divided by RE. Okay. Okay, class. So let's continue on our topic. Okay, before that, before we going further, we will recall again what the RE model, okay, for common emitter BJT. Why we call this RE model is common emitter? Because as you can see, okay, the emitter, okay, point here directly connected to the ground. That's why we call common emitter RE model, okay, for BJT. Okay, and then we have a new formula, okay, in the which is RE. Okay, RE is equal to 26 millivolts IE. Okay, so later on we will discuss how to find IE. Okay, how to find IE. Okay class, let's move to the next slides. Okay, now what we're going to do is we start first with common emitter fixed bias circuits. Okay, this one is I already draw the circuits. Okay, the fixed bias circuits, why we call common emitter. Okay, why we call common emitter. Okay, again, don't forget we have a base here, this one collector here, and then this one emitter. Emitter directly connect to the ground. That's why this circuit we call as common emitter fixed bias. Okay, configuration circuit for BJT. Alright, so we have recall, okay, how to do AC analysis and how to draw the RE model for the BJT. Okay, what we're going to do is what? The first thing is to replace the C1 and C2, okay, with a short circuit. Okay, we replace to the short circuit C1 and C2, and then we remove VCC, and then we replace the VCC with ground. Okay, let's do it. Let's we do first. Okay, now we have this one with short circuit. Okay, and then we have RB here. Okay, RB here because we have replaced with the ground. Okay, so we directly draw here. Okay, and then what we have next is we have to draw RE model on this BJT. So what is RE model? RE model, as we have learned before on the previous video, consists of what? Beta RE and we have beta IB. Okay, this one all we connect to the ground, or we can draw the straight line here. Okay, so this is our base. Okay, all of this, okay, is our, okay, let's say I draw here. Okay, so this one is our emitter. Okay, emitter, and then because we don't have a RS, we don't need to include RS. Okay, just put the VS here. Alright, and then we have a RC here. Okay, connected with the collector. RC, and then we have C2. We replace with a short circuit and connect to the Vout. Alright, so this is our RE model. Okay, we have converted these circuits to the RE model. Okay, for common emitter fixed bias circuits configuration. Okay, directly. Okay, if okay, actually we have another step. Okay, like this. Okay, so this one RB. Okay, ground, and then we have here ground, and then we have what? LC, ground, and then this one is actually C1 short circuit, C2, this one C1, and then this is our V out, and then this is our VS. Okay, so against base, emitter, and then collector. So from the original circuits, okay, before we going to complete the RE model, okay, this one, the first one is original circuits. Okay, we move to this one. Okay, that tally with the original circuits, and then based on this BJT, okay, we draw the RE model here. Okay, this is our RE model. Okay, this is our RE model, and then we just follow on the right side and then left side. Okay, this is left side. Okay, from the base point. Okay, base point here. Okay, connect to the RB right. Okay, and ground, and base point here connect to the RB and then ground, and then we have here PS here, and then also here BS. Just tally with these circuits. Okay, and then at the collector point, okay, what we have RC, right? RC, and then we just draw RC here, and then direct connect to the ground, and we have V out here, direct connect to the V out. Okay, the same thing. Okay, so we have 1, 2, 3 steps. Okay, until we complete the full RE model. Okay, for this circuit. Okay, next we going to calculate what the ZI, input impedance. Where is ZI? ZI here. Okay, ZI. Okay, and then Z out. Where is Z out? Z out here. Okay, Z out, ZI, and Z out. Okay, for the AV later on I will show you. Alright. Okay, what the formula for ZI? Okay, can we recall again formula for ZI? See, ZI equal to RB parallel with beta RE. Okay, what the formula for RE? Okay, RE equal to 26 millivolt over IP. Okay, alright. Okay, class, what our next step? Okay, what our next step? Okay, in order to calculate our ZI here, okay, RB for sure we already know the value, right? Okay, beta also is a constant value. Okay, already for sure we already know, but RE we have to find the value for RE by using this formula. Okay, this formula. Okay, RE equal to 26 millivolt over IE. Okay, in order to find the RE, we have to find IE. Okay, how to find IE? IE can be find by doing DC analysis. Okay, we have to do DC analysis. Okay, for fixed bias circuits. Okay, okay. Okay, this one for DC analysis, okay, you all already know how to do it. Okay, if you don't know, we can derive it. Okay, so how to do? Okay, how to do? We can recall get how to do DC analysis. Mm. Okay, we have what for DC analysis? We have to replace all the capacitor with open circuits, and then what? Separate the DCC, right? Okay, just recall back, no problem. Okay, so what we have here is okay, here our RB, positive, negative, ground. Okay, this is our RB, this is positive, negative, UCC, right? And then we have here this one ground, and then we have what? Our RC here, and then we have BCC, right? Okay, we have BCC, positive, negative, this one our RC. Okay, so we do all these things. This one we have IB, we have positive, negative BCE, we have positive, negative BE, and then we have IC, and so on. So to find IE, we have first to find IB first. Okay, then we will going to do KVL here. Okay, so KVL at loop 1. So all this thing we have minus VCC. Okay, plus IB RB plus PE equal to 0, and then simplify all this thing, and then now we have IB equal to VCC minus VBE over RB. Okay, and then what we have next, we calculate IC equal to theta RB, and then now what we have IE equal to IC. So we have found the IE value, okay, by using DC analysis. Okay, alright. Okay class, let's continue. So now we can calculate ZI. Okay, okay, now we can calculate our ZI here. Okay, because we have find the value of IE. Okay, just do simple things. Okay, find RE times beta. Okay, and then parallel with RB. Okay, then you can find ZI. Okay, next Z out. Okay, okay, Z out is equal to what? Okay, let me see the formula. Okay, Z out equal to RC parallel with R out. Okay, okay, let's we assume that our RB, okay, is 10 times beta RE, and our R out is greater and equal to 10 RC. So we can use Z out equal to RC. Okay, so Z out equal to now RC. Okay, simple thing. Okay, if the question asks you to include R out here, So we have to use Z out equal to RC parallel R out. Okay. By default, we just use Z out equal to RC, and then ZI equal to RB parallel with beta RE by default. Okay. If question, okay, is the question, okay, from the test or final exam ask you to consider R out, okay, you can use this formula. Okay, settle. Okay, next what we have to find voltage gain. Okay, what the formula for voltage gain? Voltage gain AV equal to minus RC over RE, or minus RC parallel R out over R. Okay. Okay, we see again. Okay, I see RC over RE, RC R out over RE. Okay, same thing. Okay, so we have determined the RE value, and then we can easily find the AV. Okay, if the question by default is not consider the R out, we just use this formula. Okay, AV equal to minus RC over RE. If the question, okay, ask you to consider R out, we have to use this formula. Okay. Okay, so settle for this circuit. Okay, now we already know how to find, first how to draw the RE model. Second one, we extend to find the ZI impedance, Z out output impedance, and voltage gain AV. Okay, for the common ammeter feed bias configuration circuits for BJT. Alright. Okay, next we will move to find ZI, Z out, and AV by using common ammeter voltage divider. Okay, we continue on our previous video. Okay, previous video we already used the voltage divider, okay, bias configuration. Okay, but for this now, okay, we'll extend, okay, a little bit to find ZI, Z out, and AV. Okay. Okay, class. Okay, this is our second circuit. Okay, common ammeter voltage divider bias configuration. Okay, so I just use what we have draw on our previous video. Okay, now we have what, the same thing. Okay, the same thing I just continue on our previous video. Okay, now we have a complete, this is a complete RE model for the common ammeter voltage divider bias configuration. Okay. Okay, let's we're going to find the ZI, Z out, and voltage gain AV. Okay, the same thing. Okay, just using the same formula. Okay, just using the same formula. Okay, what we have now, ZI equal to RB beta RE. Okay, same thing, and then Z out equal to RC, or Z out equal to RC parallel with RO. Okay, or ZI equal to beta RE if our RB, okay, is greater and equal than beta RE. Okay, same thing. By default, we just use this formula. Okay, by default, we just use Z out equal to RC. Okay, by default. Alright, so next is what? Okay, we have to, okay, let's close this formula. Okay, next we have to find RE. Okay, what the formula for RE? Okay, you have to remember RE equal to 26 milliwatt over IE. Okay, how to find IE? Okay, how to find this IE? To find this IE, okay, how to find IE? Okay, question mark. To find IE, we have to use AC analysis. Okay, we have to use AC analysis. Okay, how to use AC analysis? Okay, same thing. I move here. Okay, so we have to remember the original circuits. Okay, we have to remember the original circuits. For DC analysis, what the step is, we have to replace the capacitor with open circuits, separates the BCC, and then connects them. Okay, alright, so what we have now is okay, I draw first. Okay, we have BCC here. Okay, this one is DC analysis. DC analysis. Okay, DC analysis. Okay, so we have what? We have BCC, and then we have R1, and then we have R2, and what we have here, ground. Okay, this one ground, and then we have what? This is our RC connect to BCC. Okay, remember. Okay, now we can label it positive minus PCE, and we have here VBE, and then this is our base, this one collector, here is our emitter. Okay, so what's we're going to do is to find IB. How to find IB? Okay, you have to remember, for voltage divider, okay, we have to use what? Thevenin theorem. Okay, Thevenin theorem. Okay, we have to find VTH and RTH. Okay, we have to find VTH and RTH. Okay, how to find VTH? Okay, we have to use voltage divider rule. Okay, so our VTH now equal to what? R2 over R1 plus R2 multiply by VCC. Okay, this is a what? Voltage divider rule. Okay, voltage divider rule, and then we have to find RTH. Okay, how to find RTH? RTH equal to R1 parallel with R2. Okay, settle. Okay, so now we can simplify and redraw the circuit again, and then our DC analysis for this circuit is, we have what? VTH, we have RTH, and then ground, RC, and VCC. Okay, class. Okay, sorry, I make a mistake. Okay, this one should not be like R1 here, R2 here. Okay, actually, uh, this one VCC R1 and R2. Okay, so forgive me. So just make it correction. All right. So what we have now? Okay, actually, from the previous circuit, we have VCC R1, this one R2, and then okay, this connected to the BJT, right? Okay, BJT. Okay, so we're going to find VTH and RTH based on these circuits. Okay, we call back. So VTH, how to find VTH? Okay, based on this one, we can use, okay, we can use voltage divider rule. Okay, and then for RTH, we have to replace the VCC with short circuit. So that's why we have this one, our VCC, okay, R1, and then we have this one R2, and then we have to find RTH. So RTH equal to R1 parallel R2. Okay, alright. Okay, so we settle here VTH and RTH. Now we're going to find and derive the equation for IB and IE, because we want to find RE, okay, for AC analysis. So same thing using KVL here. Okay, so what we have, positive, negative, positive, negative, VBE. So KVL at loop 1, so we have minus VTH plus RB, no, sorry, okay, this should be RTH, okay, RTH and IB plus VBE equal to 0. So simplify this equation to find IB. So IB equal to VTH will move to the next side, VTH minus VBE over RTH. Okay, and then we find IC equal to beta IB, and then IE equal to IC. Okay, IC equal to beta IB after we found IB here, okay, by derive the equation, and then we already know that IE equal to IC, IE equal to IC, and then we will use this value, okay, to find RE. RE equal to 26 millivolt over IE. Okay, alright. So next we can find ZI equal to RB okay, parallel with beta RE. Okay, okay, for voltage divider, okay, RB, okay, actually here this is our RB, and RB equal to R1 parallel with R2. Okay, okay, so ZI R1 parallel R2 parallel beta R. Okay, beta RE. And then Z out, okay, we see the circuits, okay, no R out, okay, no output resistance here, so by default Z out equal to RC, okay, Z out equal to RC. Alright, so what happened, okay, what happened to the AV? Next, AV, okay, remember the formula for AV, okay, voltage gain, AV, okay, by default is a minus RC over RE, okay, so now AV minus RC over RE, okay, settle, okay, so now we have to find the value for ZI, okay, for ZI 1, and then Z out 2, okay, and then AV, okay, 3 value, okay, so complete okay, complete the objective, okay, for this video. Alright class, okay, so we summarize again, okay, for the AC analysis, okay, what we going to do is first, the first thing is to make sure all the capacitor, okay, replace with the short circuit, and then we have to replace the voltage source, remove the voltage source and replace the ground, and then we have to draw the RE model, okay, depend on our circuits, okay, either feed bias or voltage divider bias, okay, and then after we complete to draw the RE model, okay, we have to use DC analysis to find the RE here, okay, IE, sorry, to find the IE, and then we can find RE, okay, to calculate the ZI, input impedance, okay. Input impedance for feed bias, just this formula, RB parallel beta RE, okay, but for voltage divider, okay, because of we have R1 and R2, we have to consider this both resistor, so our RB equal to R1 parallel with R2, okay, and then what else, we have RC, okay, and then we can find Z out by default, Z out equal to RC, okay, and then if the question, okay, ask you to consider R out, you have to parallel with RC, okay, and then for the voltage gain, okay, the same thing for the feed bias and voltage divider by using the same formula, okay, by using the same formula, which is this one, minus RC over minus IC over RE, okay, RE we have calculated, so it's easy to find the voltage gain IV. Alright, okay class, I think that's all for this chapter of this video, okay. For the next video, we will continue on unbypass, okay, circuits, okay. What's the meaning of unbypass circuit, okay. Okay, for unbypass means let's say we have to consider RE here. Okay, so the circuit FRE, and then what happened to our RE model. Okay, as a little bit different thing. Okay, and then we have to use different formula for ZI, and then we will see what the formula for Z out, and then we will see the formula for voltage scan for that kind of circuits. Okay, so I think I stop here, and then hope you enjoy watching this video, and if anything else you want to discuss, okay, you can text me on WhatsApp. Okay, and then we will discuss on maybe live video, live recording, okay, on the next time. Alright, thanks for watching, and have a nice day. Bye.